Okay, so we're going to talk about visibility levels in Java once again. So there are 4. We've seen them. And we'll get to what they all are. We're going to draw our box. We're going to talk about what they mean. Okay. So our 4 visibility levels, we have public, we have protected, we have, which is also sometimes called package private, and we have just plain old private. So these are our visibility types over here. Up top, we have what they can access. Okay, what they can, or in a sense, what they can reveal, or who they can reveal it to. Let's put it that way. Who can see? So public can be seen in principle by any class. Okay, if there's a method that's private or some data member, right, some data field that's public, any other class that has access to that class can also access the method or variable. Okay, and we'll talk a bit about that in a minute because it gets a little confusing. We'll show that in a second. So any class, if it's public, right? Yeah, and now they're screaming from down below. One second, I'm gonna shut the door here. Okay, but none of these other guys can see it. These guys need extra. Boom, boom, boom. So if something is private and it's just any class without any extra anything, then yeah, you're not going to be able to access that. So let's talk about what those other conditions are. Suppose 2 things are the same class, right? You have an object of a class that wishes to access a method of that class. Well, there's no sensible way to restrict that, right? You can't really restrict an object from accessing its own methods. Why would you even do that? It doesn't make sense. So if 2 things are the same class, they can access that method if it's private, if it's any of these, same class, you can access it regardless of what the visibility modifiers are. For example, let's create a class here called vtest. And of course, right, even if I have a private method, let's call it method 1, void private, private void method 1. Of course I can still access it, right? I can create a method vtest, and I can access it, vtest v new vtest, and then v dot. Of course, I can do method 1. There's no problem, right? But let's suppose if I make a second class vtest2, right? We understand this. We've seen this before. vtest2, and if vtest2 has a method, let's call it void method 1, and I try to create a new vtest object, right? So vtest v equals new vtest. And I try to call it from over here, right? V dot, I don't have that. I don't have that method 1. Okay, can't access it. I get the error over here. It says the method 1 from the type vtest is not visible. Because I'm trying to access it through a different class, I can't access that vtest object's private method. Okay, so that's what private means. But if it's in the same class, yeah, I can always access it. So if I'm trying to do it within the range of the vtest class definition itself, yes, I can always access it. If I try to access it from a different class, even though I'm accessing it through a vtest object, I can't, right? Because I'm doing this within the scope of vtest2's class definition. Okay. So the next one The next criterion, well, suppose they're in the same package. Well, if they're in the same package, of course I can access it if it's public, right? That's a given. Public can access anything. Whoop. Whoop. If something is protected, I can also access it. We'll talk about that in a moment. If something is the default level of visibility, right? So package private, then I can access. So if it's in the same package, regardless of whether it's the same class or not, I can access it. So let's go back to our code. Over here in vtest, suppose I have a method that's package private, right? Just the default method, and I call it method 2. Well, guess what? They're in the same package, and it's package private. So over here, vtest2, if I try to call v dot method 2, there's no problem. I have visibility for that. This method 2, it's package private, which means I can access the method either within vtest's own class definition or through another class that's in the same package, right? It's part of a related group of packages. Java includes this, so I don't have to, worry about visibility for absolutely everything I do. It just says, yeah, they're all in the same package, fine. They're working together as a group. They get access. Okay, the last one, and if they're private, of course, if it's marked private, same package is not sufficient to get access. Now for the last one, the last bit is in inheritance hierarchy. Okay, if they're in an inheritance hierarchy, that's what protected is for. So protected says, you know what? If you're the same class, fine, you get access. If you're in the same package, fine, you get access. But protected also says, if you have two classes that are in inheritance hierarchy, for example, class B is a subclass of A, or class A is a superclass of B, then there's going to be a certain amount of access they have to the methods. Reason is, so you can do things like call the superclass version of the method, and so that the subclass can inherit the method. So in that case, yeah, there's going to be some access available. And again, with public, it's always there. So that's what these visibility levels mean. Private, only for same class. Default, let's, we're going to bump that up a little bit so I have space. Same class or package. Okay, protected, of course, is going to be same class, package, same class or package, or in inheritance hierarchy, and public is it exists. Okay, now I still might not be able to access the class directly if, for example, if it's in a package and I haven't imported that package. But once I have access to that package where the class is stored, if something is public, I can access any element of it. All right. So now I'm going to import some classes, some things that I wrote up on my other machine. I have them here in my download, so I'm going to pop all these open. So the first thing I'm going to do is note that this code is not really going to work unless I generate some extra packages. So I'm going to make a new package in here, a couple new packages actually. I'm going to call them vtest and vtest2. We'll do that. We'll make a new package. Oop, really wants to do that. Let's do that. There we go. So we'll make one called vtest, and we'll make another one called vtest2. Okay, so now we have two new packages, and when I import files into there, then I have access to these additional features. Without this, some of the stuff like protected doesn't work quite the way it's supposed to, because you need these extra package references in. All right, so in vtest, I'm going to do vtest2 first, because that's where these two first classes go. Let's see here. We have Visibility demo. We're going to do visibility superclass first. That's the one we really need. So that one goes into vtest2. Okay, so I have this. These two I'm going to destroy because I don't, well, I guess I don't need to. I'm just going to make them go away. Get rid of all these classes so they're not cluttering up my screen. Okay, so vtest2, I'm going to create a new class and call it visibility superclass. We're going to put all that in there. Okay, so visibility superclass doesn't do much, but it's a demo for these various visibility levels. Okay, the only thing that's an error here is this visibility subclass, which I have not yet included, right? And here there's no visibility subclass that it finds there. So we're going to bring that in. Next one. Okay, visibility subclass is simply a subclass of visibility superclass. And I'm going to put that in the vtext. Oh, vtest, no wonder that wasn't happy. Okay. Okay, so I'm going to call this visibility subclass. Okay. And there it is. Now here, let's see what you don't like. Vtest. Yeah. Okay. So that exists. Now these guys can see each other. Okay, I have a visibility superclass. Let's walk through this a little bit. So number one, it has two variables, x and y. I'm going to show you a couple neat things with this. So first of all, let's bring in the other thing. If I try to create a subclass of the superclass, right, I don't actually inherit this private data member. We'll show you, that'll be one neat thing. A few others we'll get started with in just a minute. Let me grab this last file, visibility demo. Oh, I'm going to do it once again, vtest. Okay. So we're going to put that here in vtest2. We'll call it visibility demo. Okay. So visibility demo, we can do a few things. First of all, a visibility demo object has two objects, a visibility superclass and a visibility subclass. And we're going to use them to demonstrate some of these visibility issues. All right, so first one, if I create this visibility demo, and it's going to have, in the constructor, I'm going to create a new superclass and a new subclass object. Now watch what happens with the constructor. So over here, the superclass constructor, it prints out creating visibility superclass object. The second one says creating a visibility subclass object. So you'd think that each time I call the constructor, right, it's going to call just that one. So when I run visibility demo, I should get one line for the superclass, one line for the subclass. Well then, let's see what happens. I'm going to put in another bit of and down here, okay, that'll make it a little clearer. What happens, first of all, when I call the superclass object, yeah, it goes to that constructor, but when I call the subclass object, it first goes to the superclass constructor and then the subclass constructor. That's because in Java, we have a principle called chain constructors. Constructors are called chains. That is, for every class, we start with objects constructor and then call in order all the constructor methods down to the actual class itself. Okay, so for example, with V superclass, visibility superclass calls object, then visibility superclass. For visibility subclass, we first call object, then visibility superclass, then visibility subclass. And the logic for doing this is to make sure that the objects are correctly specified, even if the user doesn't know exactly how to specify everything. For example, if you're creating a J-frame, right, there's a whole bunch of stuff that needs to be specified up front. It would be an extra hassle for the user if they would need to actually go back through the entire sequence of classes and specify everything that needs to be specified. You don't want to put the user through that. This way, you can say, yeah, I don't actually know anything about the superclasses, but I know when I create this subclass object of one, the superclass constructors will have all been called and it's going to be created the way it's supposed to be created. Okay, so essentially, this makes modular coding much, much easier. You don't need to know much about the superclasses in order to create usable subclass objects. Okay, so that's why there it's kind of a strange thing. But again, if you're creating subclasses, you need to be a little bit careful of what you do in your constructors because they're all going to get called. So you don't want to do, in most cases, you don't want to do too much because if you're, involved in some heavy-duty computations in the process of creating an object, then every subclass object of it's going to have to go through that same stuff. Okay. Second thing, that's just kind of an interesting thing, but that's the reason why Java does that. And now let's look at some of these visibility issues. Okay, so I go to my superclass. So I have a method here where I create method 5. I create a subclass object. So this is the superclass class, but I'm trying to access a subclass object and the class is in a different package. Okay, so vsub, I can access a couple of the methods. I can access method 4. Let's go look at that. Method 4 is inherited, it's public, right? So superclass has a public method 4. Sure, I can access that, but I can't access method 2 because method 2 is package private. And here, subclass is in a different package, so I can't access it. Likewise, method 1, visibility subclass doesn't even inherit that one because method 1 is private. Even if I try to do something like see what's accessible for this object itself, all I get is 3, 4, and 5. I don't inherit 2 because it's not visible to me at this point. Likewise, I don't inherit 1 because it wouldn't be visible to me ever. So some strange stuff here. So again, then method 5, I only inherit method 3, method 4, method 5 from superclass in different package. Method 1 and method 2 methods are not visible. Okay, so method 1 is private and method 2 is package private. So again, not the same class, not in the same package, so I don't have access to them. Okay. Let's say this dot method. I do get a method 3. Even if I didn't have a method 3, let's see what happens here. I still have it. See, I can get to it from the superclass. And this is a nice thing. This allows me to do things. For example, if I want to override it, I could call super.method3. It's useful to have access to that, even if this class, superclass, is in a different package. Like, for example, the graphics methods that we overrode, those were protected. This allows me to call the superclass version of method 3. So for example, I'm making a custom J panel, I can call the superclass, if I make a custom subclass of J panel, I can call the ordinary J panel methods to draw it the conventional way that a J panel would be drawn, and then add custom graphics on top of that. Okay, so it's protected is handy if you want to use a method from something, but you don't want anybody outside of that inheritance hierarchy to be able to use it. Likewise over here, if I have my visibility superclass, let's save this because those errors cleared. Oh yeah. I can just call them all. Okay, so those I get all of them. But visibility superclass, let's see. So if I want to do the same thing, I have a visibility subclass object called vsub. Let's see what methods there are available. Well, there's just method 3, and that's actually the superclass version of it. And method 4, again, superclass version. So let's call method 3. See, it doesn't even like that. It says method 3 from the type visibility subclass is not visible. So it only works one way, which is kind of a weird thing. So I can say, don't have access to vsub.method1 private or vsub method 2, just package private, because again, they're in different packages. Don't have access to vsub method 3 because superclass, even though they're in an inheritance hierarchy, it only goes one way. The subclass can access the superclass, but the superclass can't access the subclass version. However, I can, if I want to, I could say vsub.method3. I could access it that way if I typecast it. So I could say, do something like this. Okay, if I wanted to do this, let's see, I have to go through here. Visibility superclass b super equals this one, right? I can transform it, and that's fine. And then I could do b super, I get all of them, right? Because I'm doing it through this. And then I could do it, right? But normally I wouldn't have access to that, okay? Do I have access to method 4? vsub method. I do have access to method 4, which is public. I do have access to vsub method 4, which is public. Okay, so that's how visibility works. Again, it's kind of a weird thing until you get used to it, but the short version, we're going to go back through this, right? Private methods or data only accessible by the same class. Default package private is accessible by any other classes that are in the same package or the same class itself. And the same class is obviously going to be in the same package. Protected, it can be accessed directly if, what's the phrase I'm looking for? The subclass can always access the superclass version of the method, and the superclass can, of course, typecast the subclass object to itself and access it that way. But it has to go through that filter. But they can access it. And public, well, public, as long as the method exists, you can access. As long as you have access to the package where that class is stored, you have access to any public methods or data within them. Now, the second question, why do we need this visibility stuff? Right? It's kind of a headache. It is kind of a headache, and it's weird to learn. It takes a while to fully absorb how to use it, for sure. So let's discuss that briefly. Why is visibility even a thing? Why do we need it? Well, one thing, if we're doing these little dinky programs, for the applications we're designing, we kind of don't. We really don't need it, okay? It doesn't do much good. It's a headache to set up. It's a lot of overhead and a lot of worry for things that don't really matter much. But for serious, large-scale enterprise applications developed by large teams of users, yes, it's very important. The reason is this. Suppose you have two classes, right? So for example, you have a GUI class and you have some back-end database. The GUI class shouldn't be able to just reach into the database and get access to anything it wants to, whatever it wants to do. So for example, suppose we're talking about a bank account, because bank accounts are easy to understand. Suppose there's a bank account class, bank account object. Now, there's going to be a balance value in here, balance X, or balance val, balance B, let's call it balance. Okay, if balance is public, then the GUI could be coded to just reach into the banking object, right, the bank account object, and assign literally any valid int value to it, right? I could do something like bank account BA, right, as a new bank account equals new bank account BA.balance equals 1E6, right? Something like that. So equals 1 million or 1 billion or 2 billion, which is also a valid int value. So we wouldn't want that to be able to be done. That would cause a lot of havoc if somebody could insert some trouble like that into the GUI. However, by making it private, or in many cases anything not public, if balance is private or otherwise inaccessible to the GUI class, then the GUI class can only access that data through appropriate methods, right? So for example, like credit or debit, right? Or read balance. So any of those, sure, credit will add something, debit will take something out, read balance will just tell you what's in there. But those can be specified to only permit appropriate inputs with, you know, appropriate checks on any changes. So I can't just reach in from the GUI and automatically set that balance up to 2 billion. I have to go through some method with the backend database where, for example, if I'm depositing money, that deposit has to be verified, and then that has to, you know, be set to update the balance that way. Or again, if I pull money out, I can pull it out and call the debit method, and once the money has been verified as going out of the machine, then I can update the balance appropriately. Point is, GUI can't just reach into this object, change whatever it wants with no consequences. By concealing these data, right, by concealing them behind some sort of privacy boundary, some sort of visibility constraint, I force the other classes to go through those appropriate methods. Otherwise, they can't access that data at all. Okay, so again, very useful. And aside from just the security aspects of it, this is also good. This is also very good and useful for designing modular code. because it forces programmers to access data and methods through approved interfaces, which basically limits the potential chaos. If you give programmers access to reach in and access any stuff in the other classes, then there's a wide range of possible consequences. Some things could go horribly wrong. However, if you say, the only way I can change balance is by going through a credit method, that makes it much easier to test. You just test that your credit method works correctly, and if it does, you know the balance is going to be fine. Likewise, you have a debit method for pulling money out. The only way to change that balance is to lower it is going through the debit method. You just greatly simplified how your system works. Okay, so makes large, complicated systems manageable. Without that sort of concealment of data, you'd have to be concerned anytime somebody changed some code, they wouldn't have standard interfaces to go through, and the testing process would be much, much, much more painful. Okay, it would be easier to slap together a program that worked quickly, but the downside is there would be a lot of unpredictable outcomes. People miss stuff, people mess things up. If you force them to go through standard interface methods, then you know what's going to happen, basically. You're going to limit the amount of craziness that you have to deal with in your system. Okay. So I hope that makes sense. I'm sure that's all a bit abstract for you guys who are not professional coders. I get that, but trying to give the logic of it here. So what did we learn today? Well, we had a minor thing where we learned about chain constructors. We learned about the 4 visibility types, what they mean. We saw how to implement different packages and assign classes to packages, and then import them, be able to access them like we've done. And then last, we talked about visibility and why it's important out in the real world. So that's it. That's what I got for today. Questions on any of this stuff? I hope it's useful, although I guess unless some of you guys go off to be, you know, Java coders, it may not be. But modularity is a big thing out in the real world these days. So understanding some of the advantages and importance of that and why modular systems are important. I guess just knowing visibility is one angle on that. Any questions? Anything requires a little extra explanation? We're all good? Oh, and I'll post up that code, you know, for application assignment 1. I'll make that available sometime after midnight so that people, if they want to get started on application 2 this weekend, if they haven't already, you have a starting point there. Okay, anything else? Anything else I need to know about? All right, that's all I got then. Have a good weekend. I hear the weather's supposed to be nice for a few days. All right, we'll see you next week.